Hello everybody and welcome back. We're looking in this video at question number 23 on our Pascal contest from 2019. A path of length 14 meters consists of 7 unshaded strips, each of length 1 meter, alternating with 7 shaded strips, each of length 1 meter. So this sort of path that they've got down here. A circular wheel of radius 2 meters is divided into 4 quarters, which are alternately shaded and unshaded. So here's some shaded bit, and then we've got some unshaded bits. The wheel rolls at a constant speed along the path from the starting position shown, and then we're heading off in this direction. Okay. The wheel makes exactly 1 complete revolution. The percent of time during which the shaded section of the wheel is touching a shaded part of the path, so shaded has to match up with shaded, but we don't seem to care about unshaded matching with unshaded, is closest to. So we want a percent. That's what we're interested in. So great way to calculate percent would be figure out the total distance that the wheel travels, which should just be 1 circumference if we're doing 1 revolution. This sort of unspools out. And some of it will be shaded, some of it won't be shaded. And we can probably find where it overlaps. We'll count up the length of that there's overlap that shaded meets shaded, and we'll divide by the total length, multiply by 100%, and we should get our answer. And it should be low. It looks like everything's around 20%, 25%, something like that. Okay. So if we sort of imagine a number line here, how far are we actually going to go before I draw my number line? The wheel completes 1 revolution. Now, we're told that the radius was, what, 2 meters? So if that's the radius. The circumference, so the total distance that the wheel travels in 1 revolution, will be 2 times the radius times pi. So that should be 2 times 4 pi meters. And that's what? I don't know. That should be 12 something, right? So it's around 12.56 is what we're going. Okay, and that makes sense because what did they say? They said we've got 14 meters. So that's sort of just enough to go there. So okay, let's imagine a number line, and what we're going to do is we're going to sort of shade off the various parts. Now, the circle starts shaded. And it's shaded up till 3.14, about 3.14. It's shaded up to pi. And then it's unshaded from, so this distance is 1/4 of the circumference. 1/4 of the sum of a circumference of 4 pi would just be pi. And then the next pi, it's unshaded. So that's up to about 2 pi, 6.28. And then it's shaded again for the next pi. So from 2 pi up to 3 pi, which is 9. I want to say 42. I'll just double check. Pi times 3 on my calculator, 9.42. Yeah. And then for the last little bit, it's unshaded. So that's up to 12.56. Oh, about. We don't have to be super exact here. So we have shaded, not shaded, and then shaded again, and then not shaded. Okay. Now, what does the road look like? What does the path look like? Well, it's, does it start shaded as well? No, it starts unshaded. So from 1 up to 2, it'll be shaded. And then, so it's shades starting with every odd number. So it'll be shaded from 3 all the way up to 4. Now, in terms of overlap shading, they're both shaded here, they're both shaded here. So this is a distance 1. This little bit of overlap is going to be pi minus 3, however long it takes to go from 3, where the path starts shading, up till pi, where the circle stops being shaded. And then we don't really care about the rest of that, and then it'll go 5 to 6, so ending just before the shading starts here. Starting again at 7 to 8, now they're both shaded. And then 9 up to 10, but again, we're sort of cut off. We have another 1, and then we're cut off here. What's going to be? It's going to be 3 pi, this length, minus the 9 that we start from. So that's going to give us the total. So 1 plus pi minus 3 plus 1 plus 3 pi minus 9. So that'll in total be 4 pi minus 10. That's how much of the length of the road is shaded wheel meets shaded path. Okay, and what do we want to do? We want to figure out the percent. So 4 pi minus 10 over the total length 4 pi that we go, and multiply that by 100%. So just grab your calculator. 4 times pi, again 12.56, minus 10, so that's about 2.56 divided by 4 pi again. So I get, oops, I hit the wrong button. So it was 2.56 divided by about 12.56. So that's about 20.3, multiply it by 100, and we get 20.3%. Which one is that closest to? I think they were all even. That's closest to A, 20%. And there we go. So not so bad. What were the main ingredients? Well, we needed to understand how exactly the wheel was going to have its shaded part come in contact with the road. And so, okay, it starts shaded, then a gap, and then another shaded. And then we had to compare to how the road works. So I think drawing this number line is probably the nicest way to do it. Pi is not a number that works, that sort of combines well with integers. And so I don't think there's sort of a nice general way to do this. If the circumference were an integer or a rational number, I think there might be sort of a generalization you can make depending on how many revolutions you want to go or how far you want to go. But with pi's irrational, pi's transcendental. So I really think just writing out the number line is probably the best way to go. Anyway, that's it for me in this video. Up next is going to be question number 24. If you haven't taken a look at it, please do, and I will see you there in the next video.